Good morning children. We proceed on to two-dimensional geometry problems on equation of parallel lines, perpendicular lines and related to that. Exercise 6.3 question number 5. If minus 4, 7 is one vertex of a rhombus and if the equation of one diagonal is 5x minus y plus 7 equal to 0. Find the equation of the other diagonal. Given one diagonal, 5x minus y plus 7 equals 0, call it as number 1. Since we know in a rhombus, diagonals cut at right angles. The second diagonal is perpendicular to first diagonal. How to write it? Interchange x and y coefficients. That is 1x, 5y plus k equals to 0. If minus comes, you change it as plus. If plus comes, you change it as minus. So how to write the perpendicular line? Interchange x and y coefficients. Change the symbol of y. Change also the constant. Call it as number 2. Why do we do this? Because we know m1, m2 equals minus 1. Whenever two lines are perpendicular, we have slope of the perpendicular is minus reciprocal. Using that idea, we write like this. Given minus 4, 7 is one vertex of a rhombus. Minus 4, 7 does not satisfy number 1. So, it must be either B or D. So, I can definitely say minus 4, 7 lies on second equation. What do you mean by lying on? Wherever x comes, put minus 4 and wherever y comes, put 7 plus k equals 0. Minus 4 plus 35 plus k 0 or k equals 4 minus 35, that is minus 31. Put it back in second equation. My question is another diagonal. So required diagonal is x plus 5y minus 31 equals to 0 and that is the answer. Question number 7. Find the equation of two straight lines which are parallel to 12x plus 5y plus 2 equal to 0 and at a unit distance from the point 1, minus 1. Any line parallel to 12x plus 5y plus 2 equal to 0 will be 12x plus 5y plus k equal to 0. For parallel line, keep x and y as it is. Change only the constant. Given distance from, that is perpendicular distance. Perpendicular distance from which point? 1, minus 1 is unit. Unit distance tells me 1. Unit tells me 1. What is perpendicular distance formula? Perpendicular distance. I can use the formula ax1 plus by1 plus c divided by root of a square plus b square, the whole modulus. In this problem, a is 12, b is 5 and k is c. The point x1, y1 is 1 minus 1. Substituting 12 into 1 plus 5 into minus 1 plus k divided by root of 12 square plus 5 square, that is equal to 1. Given modulus, let us remember to put it. If I remove the modulus, right side I will put plus or minus 1. Whenever I remove the modulus, remember to put plus or minus 1. LHS 12 into 1 plus 5 into minus 1 plus k divided by 144 plus 25 is 169. The square root is 13. 7 plus k by 13 equal to plus or minus 1. 7 plus k equals plus or minus 13. K equal to plus 13 minus 7 or minus 13 minus 7. So K equals 13 minus 7, 6 or minus 13 minus 7 is minus 20. Putting K value back in equation number 1, I get 12x plus 5y plus 6 equal to 0 and 12x plus 5y minus 20 equals to 0. The question is to find the equation of straight lines, and we have arrived two equations. These two lines are parallel to the given line. Question number 8, similar to problem number 7. Here the idea is perpendicular. Find the equations of straight lines which are perpendicular to 3x plus 4y minus 6 equals 0 and at a distance of 4 units from 2, 1. Any line perpendicular to 3x plus 4y minus 6 equal to 0 will be. Interchange x and y coefficients. I get 4x 3y. Plus for y tells me change it as minus, also k. Call it as number 1. Given, what is the distance? Perpendicular distance. From which point? 2, 1 equals 4 units. Length of perpendicular is ax1 plus by1 plus c by root of a square plus b square. A is 4, b is 3, c is k. x1, y1 is 2 and 1. As I substitute, it is 4 into 2 minus 3 into 1 plus k divided by root of 4 square plus minus 3 the whole square and modulus is 4. As we remove the modulus, I can put plus or minus. It is 8 minus 3 plus k by root of 16 plus 9, that is plus or minus 4. Or we get 5 plus k by root of 25 is plus or minus 4. Root 25 is 5. As I cross multiply, 5 plus k is plus or minus 20. K equals plus 20 minus 5 or minus 20 minus 5. K is 15 or minus 25. Putting k value back in equation 1, we get 4x minus 3y plus 15, 0 or 4x minus 3y minus 25 equal to 0, and these are the two lines which are perpendicular to the given line and 4 units from 2, 1. Question number 9. Find the equation of the straight line parallel to 2x plus 3y equals 10, which is such that the sum of its intercepts on the axis is 15. How to write a line parallel to 2x plus 3y equals to 10? It is 2x plus 3y equals to k. Call it as number 1. The additional condition is sum of its intercepts. To write an intercept model, that is x by a plus y by b equals to 1. Right hand side I need 1. So divide by k. I get 2x by k plus 3y by k equals k by k. Or I want only x in the numerator. Bring 2 down. It is x by k by 2 plus y by k by 3 equals 1. 2 comes to the denominator, 3 comes to the denominator. We rewrite like this. Now comparing the second equation and the formula, I get a is k by 2, b is k by 3, and these are the intercepts on the axis. My question is, sum of the intercepts equals to 15. Therefore, I get k by 2 plus k by 3 equals 15. Taking LCM, it is 6. 3k plus 2k equals 15, or 5k equals 90, k equals 90 by 5, that is 18. Putting 18 back in the problem, I get equation number 1. 2x plus 3y equals to 18 is the required equation which is parallel to the given line and whose sum of the intercepts is 15. Question number 10. Find the length of perpendicular and the coordinates of the foot of the perpendicular from minus 10, minus 2 to the line. Look at the diagram. Let A be the point minus 10, minus 2. And the line is drawn here as x plus y minus 2 equals 0. The question is length of perpendicular. As I draw, what is AB? Also, foot of the perpendicular, that is what is B. So there are two questions here. We must find out AB as well as what is B coordinate. What is length of perpendicular? As I recall the formula, it is ax1 plus by1 plus c by root of a square plus b square. Here the line is x plus y minus 2 equal to 0 and the point is x1, y1, that is minus 10, minus 2. As I substitute, a is 1, b is also 1. 1 into minus 10 plus 1 into minus 2 divided by root of a square 1 square plus b square is also 1 square. Minus 10 minus 2 by root 2. Since we put modulus, I get AB equals minus 14 by root 2. Since modulus is coming, I can simply put 14 by root 2. Multiplying and dividing by root 2, it is 14 root 2 by 2, or if I cancel, AB equals 7 root 2. First part of the question, length of perpendicular is done. To find the foot of perpendicular, what is the foot of perpendicular? That is B. So this is my question. How to find B? AB is perpendicular to x plus y minus 2 equal to 0. So what is equation of AB? Remember, interchange the coefficients. I will say x minus y plus k equal to 0. AB passes through which point? Minus 10, minus 2. As I know it is passing through, I can very well substitute minus 10 minus of minus 2 plus k 0. Minus 10 plus 2 plus k 0 or k equals 10 minus 2, that is 8. So what is equation of AB? It is x minus y plus 8 equal to 0. My question is to find out what is B. B is actually the point of intersection of AB and the line. Call the given equation as 1 and AB equation as 2. B is the point of intersection of AB and the line, or I will say 1 and 2. Solving 1 and 2 to get point of intersection. First line is x plus y minus 2 equal to 0 and the second line is x minus y plus 8 is 0. As we add 2x plus 6 equal to 0 or 2x equal to minus 6, we get x is equal to minus 3. Substitute this in first equation. Minus 3 plus y minus 2, 0. In first equation, x value minus 3. Y minus 5 is 0, or I get y equals 5. Therefore, foot of the perpendicular is B, and B values are minus 3, 5, and hence the problem. Question number 11. If P1 and P2 are the lengths of perpendiculars from the origin to the straight lines, prove that P1 square plus P2 square equals to A square. We know length of perpendicular from origin to the line AX plus BY plus C equal to 0 is C by root of A square plus B square the whole modulus. Given a line, bring 2A to the left to have the same format. My length is given as P1. P1 equals to modulus of C value. C value is minus 2A divided by root of A square plus B square. A is secant square theta plus B is cosecant. So cosecant square theta. To simplify this, modulus comes, so minus I can ignore, write it as 2A. Secant square can be written as 1 by cos square theta plus cosecant square can be written as 1 by sin square theta. As I simplify by taking LCM, it is 2A divided by root of cross multiplying sin square theta plus cos square theta divided by cos square theta into sin square theta. We know sin square plus cos square is 1. So let me bring denominator to the numerator. It is 2A root of, so square and root gets cancelled. I get cos theta sin theta divided by sin square plus cos square is 1. I will rewrite this as A into. What is 2 sin theta cos theta? It is sin 2 theta. Let me recall. Minus 2A by modulus I can put plus. Cosecant square is 1 by sin square. Secant square is 1 by cos square. As we take LCM, sin square into cos square. Sin square plus cos square, that becomes 1. Denominator square and square root cancels, reciprocating. I get 2 cos theta sin theta, which is nothing but sin 2 theta into A. The same way, I can find out what is the length of perpendicular P2 for the second line. P2 equals modulus of C value minus A cos 2 theta divided by root of A square plus B square. A is cos theta the whole square plus B is minus sin theta the whole square. Because modulus is coming, minus can be ignored. I call A cos 2 theta divided by root of cos square theta plus sin square theta. We know cos square plus sin square is 1. So I get A cos 2 theta divided by 1. The question is to prove P1 square plus P2 square. What is P1 square plus P2 square? P1 is A sin 2 theta the whole square plus P2 is A cos 2 theta the whole square. As we square, A square is common. I am left with sin square 2 theta plus cos square 2 theta. Sin square plus cos square is 1. So we get A square into 1, that is A square, which is the RHS. We started with the LHS and we have arrived at the RHS and hence the problem.